The diagram shows a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. And Janet says that the volume of the cube is equal to the volume of the cuboid. Is Janet correct? And we need to show how we got our answer. Okay, so firstly, what is the surface area? Well, we can think we've got all these sides. So there's 1, 2, 3, 4, 5, 6 sides. And on here there's 1, 2, 3, 4, 5, 6 sides as well. If you think of them as 2D shapes, so here we've got loads of squares, here we've got some rectangles. If you work out the area of those shapes in 2D, of each of the sides and add that up, that's the surface area. That's different to the volume, which is the area that makes up this 3D shape. So we've been given some information for the cuboid. So let's look at the surface area of the cuboid. So we have a look at this side first. Have a look at this 2D shape. The area is going to be 6 multiplied by 8, which is 48. And because that's an area, centimetres squared. And let's have a look at this shape here. Because this length is 6, it means this length is also 6. So we've got 6 multiplied by 18 to get the area of that, giving us 108 centimetres squared. And now we're going to have a look at this top shape here. And that's going to be 8 multiplied by 18, giving us 144 centimetres squared. Okay, so we've got 3 areas, but remember I said because there are 6 sides, we need 6 areas to get the total surface area. Well, this shape here is the same as this shape here. This one here is the same as this one here. And the one on top is the same as the one on the bottom. Therefore, it's each of these twice. So what I'm going to do is add these up and multiply it by 2 and we get the total surface area. So we're going to have 48 plus 108 plus 144, which gives us 300 centimetres squared. And if we do 300 and multiply that by 2, so we're taking account for all of the 6 sides, that gives us 600 centimetres squared. So the surface area of the cuboid is 600 centimetres squared. Okay, we're told that the surface area of the cube is equal to the surface area of the cuboid. So we know this surface area must be 600 centimetres squared. So can we think of a way to work backwards and work out what the lengths of the sides are? Well, what's useful is that in a cube, we know that every length is identical. So therefore, the area of each of the individual faces, or 2D shapes, must be exactly the same. Therefore, using that fact, the area of one of the faces must equal, we're going to take the total surface area, we know that's 600, and divide that by 6, because there are 6 faces, giving us 100 centimetres squared. It's also the case that the length of each side in the cube must be the same. And again, we can use that fact. So since the area is 100 centimetres squared, each length must be 10 centimetres. And that's because 10 times 10 is 100. So if you imagine how we worked out the area previously, if this is 10 and this is 10, to get this whole area of this face here to be 100, it has to be 10 multiplied by 10. But because we now know that that's 10 here, 10 here, and 10 here, we can work out the volume of the cube. So the volume is height multiplied by width multiplied by depth. So that's going to be 10 multiplied by 10 multiplied by 10, which equals 1,000 centimetres squared. So that is the volume of the cube. Now we already have enough information to work out the volume of the cuboid, so we're going to do that. And again, height multiplied by width multiplied by depth, giving us 6 multiplied by 8 multiplied by 18, giving us 864 centimetres squared. So Janet's claim was that the volume of the cube and the cuboid were equal. However, it's clearly not, they're different. So therefore, in our concluding statement, we can say, no, Janet is not correct, since 1,000 doesn't equal 864. So we get our first mark here for finding the area of 3 of the sides and adding them up to get 300. And the second mark for multiplying that by 2 to get the total surface area. We get another mark for then using that to work out that one of the lengths of the cube is 10 centimetres. We get another mark here for working out both the volumes. And then a final mark for the concluding statement, basically saying, no, Janet's incorrect.